kids. So I think I should tell you that I've already recorded this video once and got down to 2 questions being left, and then my iPad died. So here I am starting over. One of the things I did look up during the previous video was the due dates, and so it looks like the homeworks are due 5/2. And then the time practice is due next Wednesday, and then the final can be any time next week. So yeah, we're kind of on a time crunch here. All right, so I'm going to try to get these videos out as quick as I can. I'll try to do them as fast as I can just to make it easier for you guys. I don't remember if we did polar coordinates in AP Pre-Calc, but basically polar coordinates are just another way of graphing, but on a circular grid instead of a square grid. A rectangular coordinate system is exactly as it implies, left and right, up and down. Every point has a unique identifier with an X and a Y. But with polar coordinates, there are multiple ways of naming any point, just like with olive trig. So I will say that Desmos does not support polar coordinates. I do have a little workaround, and it's basically changing. There's a way to go back and forth between polar and rectangular coordinates. And so I am going to pull up the Desmos, and I just want you to see like what polar coordinates are and how they're graphed. But I mean, I kind of want you to just visualize it, because it is kind of it's kind of a neat little thing, but it's different. So first of all, the little wrench up in the upper right-hand corner of Desmos, there's under grid, you can go back and forth between polar and rectangular graph paper. Now, that doesn't mean that it's in that mode, though, when you start typing equations. So I can make the graph paper look polar, but it doesn't mean that I can enter a polar equation and it graph it appropriately. So anyway, the first several questions, the first couple of questions are just asking you to graph a point. Just graph a point on the polar grid. So I'm going to enter this a special way. Maybe. I actually want to use All right, so when you enter something in Desmos and it has 2 variables, you can put in what are called sliders. And the A is where the angle is coming from. Oops. So I'm gonna put this in degree mode just because it's easiest for us to think that way. And then we'll do, this one can be -5 to 5. Yeah, -5 to 5. With a step of 1, and we'll do a step of 15 here. Okay, so now what this allows me to do is move sliders and let you see what is happening. So let's say, now R refers to the radius of the circle. So when you're looking at the circular graph, if I'm in an R of 1, then my dot is out 1. If I go to 2, I'm out to the second circle. If I go to 3, I'm out to the third circle. Now notice this circle's in halves, so it's actually 2 marks. 4, you get the idea. You can even go negative. Now a negative, it refers to more of a direction, which we'll get to in a minute. But so I'll just leave that at -4 because it doesn't really matter what it's at. Now I'm going to move the slider and change the angle so you can see what happens. Let me change this to 1. Hold on. 1. Maybe that, I think that'll make it easier. Yeah. So if you move the slider, you can see that it's like going around a circle. So what happens is when that's R is -4, we are on the 4th unit, and then when the angle changes, I wish I could make that go up by 1. Maybe I do this. There we go. So that is changing it, just making it go back and forth along the step. And so as you see, it's graphing in a circular pattern because it's graphing every point that is 4 units from the center of the circle. So anyway, I just kind of wanted to see show you how that looked. So in the first question, it's asking us to graph the coordinates for pi over 2. So what that means is my A is 4, and I'll make this step go back to 15. Pi over 2 is 90. Step of 15. There we go. That's not right. It should be here. It worked perfectly in the last video, just saying. Oh, there we go. I wasn't in degrees. Okay, so 490 means that I'm on the 4th dot at a 90-degree angle. I've opened up to 90, I'm on the 4th dot. Now, if I would have put a -4 here, what happens is, instead of, so my 90 degree is still going up from 0. The negative means that instead of going towards the 90, I go in the opposite direction of the 90. So I would go down instead of up. But there you go. So you can use that to check. You don't have to put in the equations. You can literally do what I did and put in the way that it's written for pi over 2, and it will graph it. Like you would write parenthesis 4 cosine pi over 2, comma 4 sine pi over 2. Like if you type that in, it essentially changes it to rectangular, and then it'll graph it for you. So we open up to 90, we go to the 4th dot, 1, 2, 3, or the 4th circle rather, and so I lost that, 1, 2, 3, right here. Okay, and that's point A. To graph 2, 8 pi over 3. So I noticed that 8 pi over 3 is something that's more than 2 pi. So I would need to subtract one rotation of 2 pi, and that leaves me with 2 pi over 3. So 2 pi over 3 is here, and I would be to be on the second circle. So that's B. All right, negative 5 pi over 6. So find 5 pi over 6, which is here. But because it's a negative 5, instead of going towards 5 pi over 6, I go the opposite way 5. So I'm going to be here. And then negative 3 pi over 4, so opening to pi over 4 puts me here. So if it was positive 3, I'd be out this way, but since it's negative, I go this direction, 3. And that is D. Okay, so this is just more plotting points. So we do negative 2 pi over 3, so here would be 1 2 pi over 3, 2 2 pi's over 3 in the negative direction. And it's positive 2, so I'm going towards that angle, so I would be here. Negative 5 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So here is my negative 5 pi over 4, and I would need to be on the fourth circle. So right here. Negative pi over 3 would be here, so this circle, or this line, but it's negative 2, so I go this way. And then negative 2 pi over 3. So here's 1 pi over 3, 2 pi's over 3. And negative is going to put me up here, and it's 4.5. So there you go. Okay, so this is asking you to name the coordinates in other ways. So I told you that there's multiple ways to name a point. For example, this would be 4 negative pi over 2. That'd be one way. I could also go up to pi over 2 and do negative 4. It'd get you in the same position. So in this whole section here, that's what they're asking you to do, is name it in other ways. So if you follow this pattern, though, it'll work every time. So when you're looking for r's to be greater than 0, that means positive r's. So we already know that these are going to be 6's. What you do is you take the angle and first subtract 2 pi. Well, 2 pi with the denominator 6 is 12 pi over 6. So 5 pi minus 12 pi is negative 7 pi. So one of them is negative 7 pi over 6. Then for the other one, you take the 5 pi over 6 and you add 2 pi. And so that would give you 17 pi over 6. And if you follow that pattern every time, you will be able to find the just two other ways to name angles when the r is positive. Okay, now we're going to do r is negative. R is less than 0, so r is negative. So I know these are negative 6. And so if you notice, whenever you're finding the negative side of it, like this is negative 4 for 90 degrees. The angle here, though, is 180 different than 90 degrees. Like 90 degrees is the angle. We're going in the negative direction, which is along a straight line. A straight line's 180 degrees. So the angles for positive and negative values of r are 180 degrees opposite. Okay, so what you, whoops, why is it not doing this? There we go. So what you do is you take the angle and you subtract pi, which in this case would be 6/6. So you subtract 180. That gives you one of them. And then for the other one, you probably guessed it, you add 180. And so that would give me 11 pi/6. And I checked all of the problems out that are asking you to do that. And if you follow that pattern, it will work. So number 4 should be this. And this. Okay, number 5 is asking us to start our conversion. So we're taking something that's polar and putting it rectangular. And to do that, you need two formulas. X equals R cosine theta, and Y equals R sine theta. If you memorize those two things, you can change anything from polar to coordinate, to rectangular. So for our X coordinate, the R is the first thing, and the theta is the second number. So it'd be 4 cosine 2 pi/3. Now, what is the cosine of 2 pi/3? Well, 2 pi/3 is a 60-degree reference angle. The cosine of 60 is 1/2. What quadrant is 2 pi/3 in? Well, it's in quad 2, and in quad 2, cosine is negative. So the X coordinate is -2. Now we do the same for the Y coordinate. And you go through the same process. The sine of 2 pi/3 means the sine of 60. Sine of 60 is square root of 3/2. What quadrant is 2 pi/3 in? It's in quad 2. Sine is positive in quad 2, so I can leave it positive. Simplify, so 4/2 would be 2. And that is your Y coordinate. So, not that bad. Number 6, same process happens, but you're using negative 1.8. It doesn't really change anything. It just means that your number is going to be a decimal instead of a whole number. But you do the same thing. And so you're going to get 0.9 square root of 2 and 0.9 square root of 2. That should be the answer there. For number 7, you should get -7 square root of 3/2 as your X, and you should get 7/2 as your Y. Make sure you're paying attention to the fact that your angle is negative here. For number 8, you should get 2 and -2 square root of 3. Number 9, your angle is pi, which is 180, so be careful, but the answer should be -16 and 0 because the sine of 180 is 0. Okay, for number 10, same thing. You should get -7 square root of 3/2 and 7/2. Now 11 is asking us to go from rectangular to polar. So the equations that you need for that are x squared plus y squared equals r squared. And then you need the tangent of theta is y over x. And the reason we choose tangent is because by definition, our other trig functions use r, like the sine is y over r. The cosine is x over r. But tangent is y over x, doesn't involve an r. So we literally can just divide your x and your y for tangent. Okay, so let's do this one. Let's first find our r. So we're going to take the x and square it. And then we're going to take the y and square it. So -5 squared is 25. 5 square root of 3 squared would be 25 for squaring 5, and then square root of 3 times square root of 3 is just 3. And so you have 25 times 3, which is 75, plus 25, 100. And so your R is 10. Now it tells us in the problem that we want an R that's positive. So we know it's positive 10, not negative 10. Now we do the inverse. Now we do the tangent part. So y is 5 square root of 3. X is negative 5. So what this is saying is the tangent of theta is negative square root of 3. And for angles that you can find the exact value of, you have to think back to your special right triangles. Or you maybe have them memorized. But if I'm looking for something that has an opposite that's the square root of 3, then I would go down to here. 60's opposite is square root of 3. So the tangent, we want the tangent to be square root of 3 over 1. Square root of 3 over 1. So 60 degrees is our reference angle. So theta is 60 degrees, or pi over 3. However, we need to pay attention to the quadrant because this isn't telling us it's negative. And so that means it could either be quad 1 or quad 2 or quad 4. But we use the original point to tell us which quadrant it's in. So this is negative 5, positive something, some decimal. Negative positive means I'm in quad 2. So pi over 3 in quad 2 would be 2 pi over 3. And that's what goes here. And so that's how you change from rectangular to polar. All right. So this one, same exact thing. You're still looking at R being positive. You should get 18, and you should get 7 pi over 4. Okay, 13. We're still going rectangular to polar. Now you'll notice, when you do your R, you're going to, let's go ahead and do it. So 4 squared plus negative 8 squared equals R squared. So that'd be 16 plus 64 equals R squared. And what is 16 plus 64? That's 80. And 80 is not a perfect root. So we have to break it down because we have to put it in exact terms. So let's do square root of 4 times square root of 20 because the square root of 4 is 2. And then square root of 4 times square root of 5, and square root of 4 is 2. So our R is going to be 4 square root of 5, and we still want a positive R. Okay, now let's do our angle. Tangent of theta is y, which is negative 8, over x, which is 4. So tangent of theta is negative 2. And negative 2 is not a value that we have in our triangles. So this is one that doesn't have an exact value. One of the ways you can tell for sure is to put your calculator in degree mode and then do the inverse tangent, and you can see that it's negative 63 degrees and something degrees. So that tells me I don't have an exact value for that one. Now, I say this all the time when I feel like I've said this all the time, but anyway, this is not a problem I've ever had to do before. Like, there's literally 0 point in writing the exact value because what they want you to do is write it as an inverse. Okay? So our angle, or our theta, is going to be the inverse tangent of negative 2. Now here's the problem. When we put in inverse tangent of negative 2, we get a negative angle. But our angle has to be written in positive form. Okay? So that's like that negative angle is kind of like your reference angle. So consider this your reference angle. That's going to give you like how far you are from the x-axis. What quadrant are we in here? So here we're in positive, negative. So we are in quad 4. Quad 4. So how do we take an angle that's written as a negative angle? Let's say negative 30, because that's something we're used to. We want to write that as a quad 4 angle. The quad 4 angle for 30 is 330. So what would I do to negative 30 to end up with 330? Well, you would add 360 or 2 pi. So the exact value for our coordinate is inverse tangent of negative 2 plus 2 pi. And that's why I say that this is pointless. Like I've never had to do this ever, ever, ever. But that would be the exact value. Okay, 14 is basically the same thing. You should get 2 square root of 29, and you should get the inverse tangent of negative 5/2 plus 2 pi. All right, 15, kind of sort of the same thing. When you square it and you get your r, it is asking us for a negative r. So when we get down to, when you do your math, you're going to get r squared equals 81, which means r is 9. But since it wants our r is negative, we have to put negative 9. Then when we do the tangent, so it'd be 9 over 2 over 9 squared of 3 over 2. Well, the 9 over 2's parts cancel. So it's 1 over the square root of 3. So back to your reference triangles. Which angle would have an opposite of 1 and an adjacent of square root of 3? And the answer is 30. So we are looking at pi over 3. Or I'm sorry, pi over 6. But what quadrant do we want it in? We want it in quad 1. Okay. However, when your 9 or your leading number, your r, is negative, you're in the opposite quadrant, 180 from where you want to be. So our point is here somewhere, but because we're graphing it with a negative, we need to have this angle so that when we go the negative direction, we end up here. So we want the angle that's 180 from pi over 6, and that would be 7 pi over 6. So you just take the pi over 6 and add 6 pi over 6. All right, 16, you should end up with negative 14 and 5 pi over 3. Same thing, pay attention. They want r as a negative value. 17, you should get negative square root of 73. And when you do the inverse, it'll be a positive value because a negative divided by negative is positive. So you'll get an answer that's in quad 1. And it should be in quad 3. But because we're using a negative r, you would want the quad 1 angle. So you can just leave it as inverse tan of 8/3, and you don't need to put plus pi. And then for 18, the answer should be negative 5 and 7 pi over 6. Yep, and there's nothing really like mind-blowing about that. All right, so there you go. There's your introduction to polar coordinates, and I will post